Hello everyone, I am Dr. Leena Chandra, Assistant Professor, Assistant of Physics, Fatima College. I am going to present an e-content on the topic Transmission Electron Microscope from the course Material Science of the program MSc Physics. The outline of my talk is about the introduction of Transmission Electron Microscope, specimen interactions in electron microscope, working of TEM, then parts of TEM, sample preparation and conclusion. Let me first tell you about introduction of electron microscope. To explore the micro world, many inventions have been devised. One of them is optical microscope. Human eye can see or distinguish objects of the order 0.2 millimeter. Using optical microscope, even you can distinguish objects that cannot be visible to the human eye. Since in optical microscope the source of illumination is light, you have a limited application. That is, the wavelength of light is 400 nanometer to 600 nanometer, so you can distinguish objects or microstructures within this range. So if the magnification of the optical microscope is raised to higher and higher, can we see atom? Unfortunately, the answer is no. Yes, to break this point, engineers like Ruska in Germany devised electron microscope. What is an electron microscope? So, electron microscope, the source of illumination is high energetic beam of electrons. So here, this is a picture of a TEM, transmission electron microscope. The electron gun is there. From there, highly accelerated electrons or accelerated towards cathode, and therefore it can produce the electron beams. So here the applied electric voltage to the electron gun decides the magnification. So also it can distinguish if the voltage applied can be varied, as well as you can distinguish very small objects like atoms. With this introduction, let me define what is an electron microscope. Electron microscopes are scientific instruments that use highly energetic electron beams to examine objects on very fine scale, in nanoscale, in microscale, etc. So these are all the information that we can receive from this electron microscope. First one is topography, the surface features of an object like hardness, reflectivity, etc. Morphology, the shape and size of the particles. Their ductility, strength and reactivity, etc. can be found. Third, the composition, the elements and compounds present in the specimen and their relative amounts can be found using this electron microscope. Okay, let's now first compare the electron microscope with the optical microscope. In optical microscope, as I said, it uses glass lens. Therefore, its magnification and depth of field is low. Whereas in electron microscope, it uses high energetic beam of electron as source, and therefore to collimate or to condense these beam of electrons, we are using strong electromagnets, which can be called as magnetic lenses. And high energetic electron beams are coming, therefore its depth of field is large, and the magnification can be controlled and can be made higher by applying high accelerating potential to the electron gun. Also better resolution. So and another point is Electrons can move freely only in vacuum. Hence, the electron microscope has to be operated in high vacuum condition, and hence the price is high. Okay, with the electron microscope, the resolution can be made very high with 0.2 nanometer, and its resolution is it can distinguish two different objects with this small size, 0.2 nanometer, and compared to the resolution of optical microscope, it is very much higher. So the magnification is greater, and in optical microscope, magnification is of the order 1000, whereas in 10, using 10, we can magnify up to 5 lakh times. Okay, there are two types of electron microscope. First one is transmission electron microscope. Second one is scanning electron microscope. So, transmission electron microscope form images using electrons that are transmitted through the specimen, whereas scanning electron microscope utilize electrons that have bounced off the surface of the specimen. Now let me explain this. The specimen interaction in electron microscopy is the main reason behind which electron microscope works. Because if the electron doesn't interact with the specimen, it cannot record the image. So these interactions only make the electron microscope possible. Now the incident electron beam interacts with the specimen or atoms in the specimen, and it produces these many reactions. So as the incident electron hits the specimen, it can be backscattered 180 degree, and this is known as backscattered electron. And as the incident electron hits the atom in the specimen, and also it just hits the atom, that is electron in the lower shell, mostly the K shell electron, and this K shell electron will come out of it. It gets ionized and it will come out of it. Therefore, we can get the secondary electron. And because of the secondary electron process, there may be some surplus energy, or there may be some surplus energy produced, which may be emitted as the form of X-rays. And as the incident electron beam interacts with the atom in the specimen, mostly the outermost, that is lower energy orbit electrons get excited, and due to that there will be some change in energy, and the surplus energy can be emitted in the form of Auger electron. So these are the reactions that are taking place at the top of the specimen, which can be utilized for examining thick or bulk specimens. Mostly it is used for the scanning electron microscope. As the incident electron or electron beam gets transmitted through the thin sample, then those can be used for TEM. These they are nothing but, first one is unscattered electron, second one elastically scattered electron, and third one inelastically scattered electron. These are transmitted electrons. These transmitted electrons are mainly utilized in transmission electron microscope. So as we have seen, the incident electrons, without any interaction with the specimen, it comes out, it gets transmitted. It gives us the information about the thickness of the sample. Higher the thickness, only small number of electrons can be transmitted. Therefore, it appears dark in the image. If thinner areas can be seen as bright, because more number of transmitted electrons, unscattered electrons will come. Second one, elastically scattered electrons. Here, some of the incident electron gets scattered by the atoms in the specimen in an elastic fashion. That means there is no loss of energy. And as there is no loss of energy, they can be also it gets scattered and it obeys Bragg's law. Means if the incident electron beams get scattered by the atoms lying in the same atomic plane, will be scattered by same angle. Therefore, these same angled diffracted electrons forms an image, forms a spot in the diffraction pattern. And as a result, it gives you the information about orientation, atomic arrangement and phases present in a specimen. Okay, and third one, inelastically scattered electrons. Electrons interact with the atoms in the specimen in an inelastic way. That means there is an energy loss during this scattering process. And the energy loss can be utilized in two ways. One is the Kukuchi bands, the bands of alternating dark and bright lines, and it gives you information about atomic spacing of the specimen. Then there is a loss of energy during this scattering. That energy is a characteristic of bonding state of the element. So it gives you information about the composition. That is the elements in which the electrons gets interacted. Then the bonding state of the element can also be studied using this electron energy mass spectroscopy. So using these unscattered electrons, elastically scattered electrons and inelastically scattered electrons, 10 image and 10 diffraction pattern can be produced. And they are the pioneers, Max Knoll and Enos Raskov. They have devised the first prototype microscope. They are the scientists from Germany. And now let us go in detail about transmission electron microscopy. TEM is a unique tool in characterization of material, crystal structure and microstructure simultaneously by diffraction and imaging technique. Now the working of TEM is analogous to a slide projector. In a slide projector we have a source of light and we have a condenser lens which is used to collimate the light on the slide, and the slide is well illuminated, therefore the image is magnified and it is projected on the screen. Using the same principle, our 10 electron microscope, that is transmission electron microscope, is also working. Here we have an electron source. From the electron source, the high energetic beam of electrons gets condensed by the magnetic lens and it falls on the specimen. Then it is magnified, projected in the photographic plate or a TV monitor. So the basic design of transmission electron microscope consists of the electron gun, where we have a constant filament which is acting as a cathode. Then there is a metal plate with a central aperture which is an anode. So high energetic electrons are accelerated towards the anode and it can be condensed and it can be magnified using magnetic lenses. And at the end of the tube, highly evaporated tube, we have a fluorescent screen or a photographic plate. So this is a design of transmission electron microscope. The simplified ray diagram of a TEM consists of the electron source, condenser lens with an aperture, specimen, objective lens, objective aperture, projector lens and screen. This is the basic model. Now the condenser and magnification lenses can be in stages. First condenser, second condenser lenses are used, condenser aperture, objective lens, objective aperture, selected area aperture to get the diffraction pattern, and intermediate lens, second intermediate lens for